Hello students, welcome to my channel Engineering Education. Please subscribe my channel. Thank you. In this video we are going to solve problem 3.7 from chapter number 3, Reversible and Irreversible Processes, from the book Applied Thermodynamics by Eastop and McConkey. Statement of the problem is 1 kilogram of air is compressed isothermally and reversibly from 1 bar and 30 degrees centigrade to 5 bar. Calculate the work input and the heat supplied. So first we will write the given data. The mass of the air which will be compressed is 1 kilogram. Initial pressure is P1 and that is 1 bar. Temperature T1 is equal to temperature T2 and it is equal to 30 degrees centigrade. Because this is isothermal process, during isothermal process temperature remains constant, so T2 will be equal to T1. And the pressure after compression is 5 bar. This is the PV diagram for this isothermal compression from 1 to 2. The direction of arrow is upward. We see that the specific volume or volume of the air decreases. At state 1 we have greater volume, while at state 2 we have small volume as compared to V1. So we can say that V2 is less than V1. It shows that this process is isothermal compression because the volume or specific volume decreases in this process. So we are required to find two quantities. One is work input and second is heat supplied. So work done from 1 to 2 and the heat supplied during the process, we will find it. So coming to the solution of the problem, it is very clear and given in the text of the book as well that isothermal process for a perfect gas, in this case air is treated as a perfect gas. So for that the non-flow equation will be Q plus W is equal to 0, because we have discussed it in problem 3.5 as well. As the temperature T1 is equal to T2, due to this the specific internal energy or internal energy will be also equal to each other. So we can say that U1 will be equal to U2. So in this case the change in specific internal energy will be equal to 0 because we have same values of specific internal energies, so the difference will be 0. That's why the right hand side for the change in specific internal energy or internal energy is taken as 0. Also the expression for work done for a reversible isothermal process for a perfect gas is also derived in the text, and that is equal to, if we write the subscript from 1 to 2, so this work done will be for this process specifically compression. So work done from 1 to 2 is equal to P1 V1 natural log of P2 by P1, where P1 is the pressure at state 1 and V1 is the volume at this point and P2 is the pressure at state 2, while P1 is again the pressure at state 1. So we have given these values in the problem, P2 and P1 are given. P1 is given, V1 is missing. So the alternative relationship for the work done, or the expression from 1 to 2, is also, we can write it from the characteristic equation of state. PV is equal to mRT. So we can replace this by P1 V1 is equal to mRT1. So this P1 V1 can be replaced by, for a perfect gas, mRT1 natural log of P2 by P1. So if we put the values in this expression, m is 1 kilogram, the value of R for air, it is 0.287 kilojoule per kilogram per Kelvin. So we will write this 0.287 into T1. T1 is given, which is 30 degrees centigrade. So converting it to Kelvin, we will add 273 with this. So it will become 303 Kelvin. So it will become T1 is 303 natural log of P2 by P1. P2 is 5 bar and P1 is 1 bar. So simplifying this, the value of work done from 1 to 2 comes out 140 kilojoule per kilogram, because in the problem it is stated that 1 kilogram of air. So this is actually the work done per kilogram. Also we discussed that Q plus W is equal to 0. We are required to also find the heat supplied. This was for work done. We first found the work done, and now we are going to find the value of heat supplied. So for isothermal process, for perfect gas, the expression of Laurent's equation becomes Q plus W is equal to 0. So we can also write that Q is equal to minus W, or the value of Q will be minus 140 kilojoule per kilogram. So this is the required heat supplied during reversible isothermal process. So we found two things, which is the work done during this compression and the heat supplied during the process. Thanks for watching. Please like and comment on my videos. Also subscribe my channel to get new videos.